I write at the end. Remember, you can make any spaces as you want, but you can make spaces. Sub-circle. If I make it 60 centimeters, that circle. So let's put here. Radius 30 centimeters. That gives me a 60 centimeter circle. Now that's too big, I think. That will airbrush your forest. Somebody in my group calls it, it's like airbrushing. It's gonna look nice, but not. See what happens? I'm airbrushing it, and everything becomes thicker. But now I think I'm falsifying reality, because that's not true anymore. However, if I look at the canopy, I did remove all the pits, but at the expense of destroying the trueness with our scan by replacing points with very big circles, bigger than the laser beam was. But you see, that's where I started. Then I added the fill. Okay, so far I didn't really do bad about the thing. Now I made it a bit wider. I think that's okay. And now I made it way too wide. Also, I like it how what it does to this tree, but it modifies everything everywhere else. There's one other way people create canopy height models that you find in literature. They use last to them. So we're done with last grid. We now try a different way. Try last to them. What last grid did not do at all, last grid does not interpolate. It does not interpolate from one point to the next. Last to them interpolates using a triangulation. And remember, we use last to them also to create the DSM. And in a way, a canopy height model is very similar to a DSM. So, except it's like a normalized DSM. It's actually often called in literature in DSM, or canopy height models are used interchangeably. And so I'm loading the normalized data. I do the same thing, step size. I do false coloring. I use the same false coloring so I can compare them from 0 to 22. And of course, now I need to filter the first returns, because that's what I do for a DSM also. If I don't filter for the first return, I will get extremely many hits, because it will interpolate in the middle of the tree also to down to the points which are on the ground. So I say first only add. Oh, and I must change the format. PNG. Okay, last to them, the normalized LiDAR input. I only keep the first returns. Elevation is false colored from 0 to 22 meters. That's a more complex operation. Now I have to compute a triangulation and sample the triangulation, but you know, it carries more files. Where's my result? Oh, I didn't give it any name, so it's called FM. So I should have given it a name. I didn't, so I just used the name of the file and gave it a PNG extension.
Nobody said anything.
But it's fine, because I didn't have it before. So if I now compare this, you see it's nice because I don't have any black. I didn't need fill because it's an interpolation, it's everywhere. It's a triangulation that's completely covering the entire area. So there are no black pixels I need to fill. But I do have a lot of pits. And they are different pits. By the way, the shift of 1 pixel is because of the making the points circles and not specifying. It made the raster 1 pixel wider. That's why there's a little shift. So I like that the black pixels are gone. But I still have pits. And how can I now remove the pits? Just doing a subcircle will not really work because I'm interpolating points. And we developed a method with LAStools to generate what we call pit-free canopy height models. And it's a complex method that uses several LAStools back to back. And now I think this would be a good point to try something we haven't tried at all before. Some of you are leaving at 11, and at least I want you to. I was planning this for the afternoon, at least do it once. Namely to use a batch script. So I provide this algorithm as a batch script. I also provide it as an ArcGIS toolbox and as a QGIS toolbox, but I'm not sure we have it set up for this. However, the batch script is readily there. We just need to modify it slightly. You don't need to follow all these steps because they may be a bit too complicated. But I want to show you now, so you sort of get a first intro and a very simple example of how I can do something with the batch script. Because I could now go through all these steps hand by hand that the batch script does, but that would take me longer than making the modifications. So I told you there are some batch scripts with LiDAR, with LAStools, and they are in the example batch script folder. And that's one thing that's called generating a pit-free CHM beam width. That means that's that beam width we just talked about. So I will now, you can follow along as you please, but I will not be slow enough to make sure everybody can do this. This is based on on the paper we had last year in simulator or poster. The paper just came out in the PERNS journal of the ASPRS. This is how a batch script looks like. When it starts with 2 columns, it is 2 columns. Yeah, it is a comment. I always like to comment my batch scripts because they're also meant to be educational. So the first one tells your system where LAStools is, where the bin folder is. In this case, I actually use it on the H folder, H drive, LAStools bin. That's where my installation is. Now I need to tell it where my LiDAR is, the one that's already normalized. Okay, so I go, where's my normalized LiDAR? It is in bin, centered, Agno Forest, it's right here. And I can just go up here and copy and paste, and I know it's going to be ffn.las. So I go back here and I put in that file. The normalized LiDAR is right here. Forest / ffn.las. My desired resolution, that's the step size, it is 1.0, 1 meter. The beam radius, I said, yeah, 20 centimeters is a good beam diameter, so 10 centimeters should be the radius. The sub-step, half, it says here, about half the step or less. Half the step. My step is 1, so I set this to half. And then it says here the desired triangle kill. That's very similar to the triangle monster. I set that, it says here about 3 times a step. Well, I follow the, just follow it. You can read the paper for all the details, otherwise just follow the recommendation. Now I need a temporary directory. A temporary directory for the beam file. Okay. Yeah, that's probably good. Temp CHMs. It's just coming. So it will use wherever I am and create that. If you can't write in that place where you are, then you need to get a more longer folder. It will create it and delete it. So don't use anything where don't use a directory that already exists, because that would be not good. And then where do I put my final output? And here I must make a bigger change. My final output should go into this directory. But you see, in this case, I produced actually a CHM. It's not a false coloring. It's a CHM with height values in the file. So I must modify for this particular exercise. First, I'm going to call it CHM hit3.png. But I also must now go and modify the script to produce a false coloring, so I can properly compare to all my other results. This produces a real CHM, the script like it currently is. So I go to the very end where it creates the final output. It uses this last grid. Or maybe I quickly tell you what the script is doing. Script now will create the temporary directory. That's what these two did. It will delete it if it's there. So that's why it's careful. Don't use one where you have important information. It should be a temp directory. Then it creates it again. This is a simple way of making sure it's empty. What I do then, I take the normalized LiDAR as input. I specified it above. I take the highest points. And I use LAStThin. We haven't used it yet. LAStThin puts a grid over it and keeps the highest point. Very similar to LAStGrid, but it keeps the points. It doesn't create a grid. It keeps the points. It's like a filter, but a bit more complex filter. And it also has subcircle. So it keeps the points, but it turns every point into a disk. So points are now replicated. They can appear twice when they fall into two grid cells. And it creates a new LiDAR file that's temporary, called the beam LiDAR file. That's full of points which are very high in the grid, and possibly in the neighboring grid cell, because they are allowed to spill over, because they are now a little bit bigger than a point. They are a circle. And this will be the thing that's going to be used for input. And then it uses the beam LiDAR that was created as the input to the next algorithm. And that's LAStools. So LAStools just like LAStools, just creates a CHM and puts it into the temporary directory. Just a standard CHM with 1 meter step size, and it puts out in the PHIL format. It gives us an appendix, because I create now more. So that's the one at the bottom. It uses all the points. And now, I only use the points that are 2 meters or higher in the tree, because I'm dropping every point that's below 2 meters. That means all the ground points are gone, all the shrubs are gone. I only take the higher points. And I'm computing again a CHM with the same steps as 1 meter. But now I put in the triangle monster and I kill away everything from the canopy that is higher, that is bigger, when the triangles are bigger. And this way, I'm eating away the triangles between the trees when the trees are far away from each other. Whereas the triangles that are part of the same tree are still there. The same idea with last boundary, when we created the boundary polygon. And I do that several times. I do that for 2 meters, 5 meters, 10 meters, 50 meters. So I'm cutting the canopy into layers and remove the points that create the pits. If there are no, it's not important you understand this. The algorithm is very clearly illustrated in the paper or in the poster with images. But I wanted to show you how you can put together multiple things. We create different outputs by giving it a different appendix. Every time it gets a slightly different name. Different name. That's a 50-meter partial CHM. We call these partial CHMs. And because our trees aren't so high, we don't actually need these very high steps, so I just delete the very high steps from my script. So, and in the end I merge them all together, because I told you LAStools can read the PHIL format, and I'm keeping the highest. That means I'm keeping from all these partial CSM the highest point, and I'm output the final one. And one more thing I need to add now, the final one should also be false colored minus set min max 0.22. I already specified PNG format ups there. Usually, I only do this so we have the same visualization. Usually I wouldn't have to do this when I create the actual CHM. So now you saw me. I use the same script again and again and again, all the time. And all I modify, I never modify all these complicated things that took an entire paper to figure out and to validate. This is the pipeline that stays almost the same. Usually the only things I have to change are the things up here. And now I save it. Of course now I lost my original. I still have the zip file somewhere. Usually I save it to a different name. And I hope I didn't make a mistake. Did I make a mistake? I will find out when I run it. How do you run a batch script? Well, either you type the name in the command line or you just double click it. So I just double click it. And then all these things happen. And now you see the black window it executes the last thin. It thinned it. Now it uses this temporary file it created in the last step to create the first CHM, and the second CHM, and the third CHM. Imagine I would have to do that with a GUI each time running LAStools, and the next one. And now it merged them all together into one, and done. Imagine I had to do all these steps with the GUI, because I'm using ArcGIS. That was mean. So, you can also script in ArcGIS. There are scripting languages too. This same exists as a toolbox in ArcGIS also. Of course, it's impossible there to just go in and say, now give me a false coloring. They will always give you a CHM. But when you have a CHM, you can always easily generate false coloring with GDAL, for example. You don't need to use LAStools. But let's see what it created now. The CHM pit free. Let's look at first the other one. That was the one just using interpolation, and it had the issue that here was still some pits, and now and that's a pit-free one. The only other way to get rid of all these pits was to make an unreasonable assumption about the laser beam width. And that makes it incorrect everywhere. Like these power lines become like 2 pixel wide suddenly. They should never be 2 pixel wide, a power line. But they become 2 pixel wide if you make the laser beam width 60 centimeters. But we were able to achieve the same pit freeness all these little pits here. They all got away. So now I demonstrated 2 things. What I think is a sort of really good algorithm for generating pit-free CHMs, which you subsequently can use for single tree detection, for example. That's now you have a raster, and then you would run a raster algorithm for single tree detection, like finding a localized. Maybe you're running a Gaussian smoothing on this one, and then running a localized minimum finding, or do some kind of erosion and what's the opposite of erosion in image processing? Space random. Morphology operation, erosion and dilution. Dilation. In morphological image processing, there's this. One is called opening and one is closing operation. I know, these are typical operations used in image processing in all these recognition softwares and so on. These are standard operators that can also be used to find then the individual peaks, and then use those to localize where the trees are. But more importantly, I gave you a very scary introduction to the batch processing. But because you have seen the individual, every time you run LAStools, you see these command lines, and it wasn't quite as scary as it would have been had it done it on day one. Because you already can read it more or less. You can read the command line now. Because every time we do it, I'll go through it. That means without you noticing, I've taught you the command line. that's sort of all my knowledge about how to create good CHMs. Of course, to generate CHM now, just leave out the minus false, leave out the minus set min max, and produce a TIFF or a bill or a ask, and then you have the actual CHM. But for visualization, for these looking and comparing, having the false colored one was nice. And in that process, I lost the KML file, unfortunately. I could have put minus UTM 51N at the last step too. I do have it here, so this was also pretty okay. There we go.